The general communication system for satellite. Let's see the overview of it today. So we know in today's life, satellite plays a very important role. Without satellite, we cannot imagine even the life today. And if you see the satellite, there are various categories of satellites and various applications of satellites. We use mostly in general everyday's life. We can see television broadcasting, internet connectivity, telephony, and if you want to know the weather, it is used for weather, for military applications. So like this, for various applications we use the satellite. Now let's see what are the components which are present in such a satellite. If you see the satellite, the entire system of the satellite can be divided into three segments. One we call it as space segment, and another we call it as ground segment, and another we call it as telemetry, tracking, and command. So what does the space segment consist of? Space segment consists of the satellite. And what does the satellite consist of? So satellite is used mainly for communication, so to capture some information and to send to the earth, or from the earth it receives the signals and retransmits back the same signals. So we need some antenna subsystem in the satellite, and in order to functioning of these antennas, whatever subsystems we require, all those subsystems are present in the satellite. For example, we need the power, so power subsystem is present in the satellite, and we require the electronics, some of the electronics, computer we need, so it is present in the satellite. So like this, there are various different subsystems present in the satellite, and these subsystems enhance the life of the satellite or the functioning of the satellite. And another segment we have is the ground segment. The purpose of the ground segment is to transmit the signal to the satellite as well as receive the signals from the satellite. So the ground segment also plays an important role in transmitting as well as receiving the signals. And ground segment is the one which is connected to all the networks on the ground. Take the data from all the networks to the satellite, and from satellite again to the destination point. So, for example, if a user wants to make use of a satellite for mobile communication, then the user dials a number in his mobile unit. Then that dial number, suppose if the number has to pass through the satellite, or if it has to be connected through the satellite, then the call will first go to the nearest mobile station, and then it to the switching office, mobile switching office, and from there it is connected to the earth segment, that is the satellite base station, and from there the signal is transmitted to the satellite. So what do we require in between the user and the satellite is that the user has to be connected to the nearest cell station, and that is through the wireless, and the base station is connected to the central switching office of that base station, and that we call it as the central switching office or mobile switching office we call it as. And that mobile switching office, through the cable, it is connected to the satellite base station, and from there through the antenna, and whatever changes we have to make with the signal to the signal, so that it can be propagated to a satellite, all those changes such as multiplexing, modulation, encryption, and assigning the power to the satellite, and all these components processes will take place at the earth station, and then the frequency is converted to the uplink frequency. So if you want to communicate with a satellite, we can communicate only through the uplink frequency. An uplink frequency is a frequency which is used to transfer the information from that is a earth station, to the satellite, and the satellite receives that signal. Again, the signal will be amplified there, or if any necessary modifications has to be made, some modifications are made, and after that the signal will be retransmitted back to the earth station again. So before retransmitting, the signal has to be amplified so that it has to travel again from satellite to the base station, and from there, from that particular, using the antenna at the satellite, the signal is retransmitted, and it is converted into downlink frequency, and then that downlink frequency will be propagated to the other earth station. Now all the earth station again receives the signals, and whatever changes we have made at the transmitter section, that is multiplexing, if we do at the transmitting side, we have to demultiplex it at the receiving side. Whatever modulation we have done at the transmitting section, using the same technique, it has to be demodulated. And if encryption of the information has taken place at the transmitter, the decryption has to be done at the receiver side. So after receiving the signal from the satellite, the base station has to make all the necessary operations or the reverse operations which has done at transmitter. Then after that, the signals has to be transferred to the proper destination through the terrestrial network. And once the signal is received to the terrestrial network and to a proper destination hub, that is maybe a mobile switching office or a telephone switching office, then the signal will be transferred to the user from there, whatever means, whether it is a wired or wireless, in any way the user may be connected. So like this, the satellite structure will be from end to end, from one user to the other user. If you see, the communication will go on in that manner. And the if you see the process here, the signal is transmitted to the satellite using uplink frequency. The signal is transferred from satellite to the earth station using the downlink frequency. This is how the satellite system will be. We can see that there, what are the processes we need there. And the type of frequencies which we use are L band or C band, KU band, KA band, or S band we can use. So any of the X band also we can use. So these are the frequency bands which can be used for satellite communication, and these frequencies range from 1 gigahertz to 30 gigahertz mostly. So in order to transfer the information via satellite, we choose microwave frequencies mostly. And the satellite revolves around the earth in different orbit. Orbit is the path in which the satellite will be moving around the earth. Now that path, if the satellites are launched very near distance to the earth's surface, then we can call it as a low earth orbit, where the radius of the satellite or the distance of the satellite from the surface of the earth may be 160 kilometers to 2000 kilometers. And if it is a medium earth orbit, it is from 2000 to 36,000 kilometers. And if it is geostationary orbit, the satellite will be launched at geostationary orbit. And why we call it as a geostationary orbit means, the satellite with respect to the earth, the position of the satellite with respect to the earth is always stationary, because it moves with the same speed as that of the earth in that particular space. Whatever required speed we need there, with that speed the satellite will be revolving. So the specialty of this orbit is that if you want to focus a particular geographic zone, then continuously, then we can go for the geostationary satellites. Thank you.